So this one was all from rational functions unit. So this is a rational function because the function is set up as a fraction. And so three of these depend on what numbers make the numerator 0 only, the denominator 0 only, or it makes them both, the numerator and the denominator 0. So you need to think about what numbers make the numerator 0 and what numbers make the denominator 0. Well, the numerator never equals 0. Negative 2 is never equal to 0. The denominator equals 0 at 4. So poles occur when you have the same number that makes the numerator and denominator 0. X-intercepts occur for numbers that make just the numerator 0. And vertical asymptotes are vertical lines that occur for numbers that make just the numerator 0. Very, very little work to be done, but you either remember those rules or you don't. There's not much else you can do about it. Horizontal asymptote is one where you have to compare the degree of the numerator to the degree of the denominator. For this one, the degree of the numerator was 0, because there's no x's. And the degree of the denominator is 1. And anytime the degree of the denominator was bigger, the horizontal asymptote is at like 0. So it does not have a slant asymptote because the degree of the numerator is not 1 bigger than the degree of the denominator. So main, we need to say what x values we can plug in. And we can figure that out by figuring out what numbers we can't plug in. So we can't plug in 4 because that's division by 0. The range, we really need to see the graph to be able to answer range, so I'm going to come back to that one. And probably the easiest one is y-intercept, because that is when x is 0. You get negative 2 over negative 4, which is 1/2. So usually what happens is, if you can do all this, and all this is correct, and you put it all on the graph correctly, usually you're very close, if not having enough information to actually sketch the graph. So sometimes you have to plug in a few more points. So think about making a table and just plugging in any easy x value. That would be easy to do, because that would be negative 2 over 1. And of course, the more points you plug in, the more confident you're going to be about your graph. So I'm not trying to say that you have to do a certain number there. But understanding how the graph interacted around these asymptotes was how it all kind of came together. At the ends of this graph, it has to get close to the horizontal asymptote, so I know that looks like that. As I can see, this is slightly going up. The vertical asymptote, this side's going to spike up, which means this side's going to spike down, which is good and consistent with this one extra point that I went ahead and found. And just like it has to get close to the horizontal asymptote here, on the left side, it has to get close to it on the right side as well. So now I can see my graph. Now I can go back and answer range. It hits all of the y values except for 0. So it hits all of these, which is negative infinity to 0. And it hits all of these, 0 to infinity. Range is almost always impossible to answer unless you can see the graph. There's not a good algebraic way to do range. So I just verbalized all those rules again. I didn't say anything different than before spring break when we did this. However, if I said one of those rules or a couple of those rules too quickly, or you need to write them down, I'm going over them in more detail. So, any specific questions about the first little graph? Any clarification you want? Okay, and let's look at one more. Because it's impossible to have a slant asymptote and a horizontal asymptote, so we can't ask you just one of these because we couldn't test to see if you knew both of these. It's also not always possible to get a whole, so that's why there's typically more than one. But the exact same rules apply here. I care where does the numerator equal 0 and the denominator equals 0. 2 and negative 3 for the numerator, 2 and negative 4 for the denominator. So numbers that make just the numerator 0 are x-intercepts. Just the denominator 0 are vertical logs, vertical asymptotes. And if there's a number that makes them both 0, that's when you get a whole. Remember, each one of these can only be one thing at a time. There's 3 different things. If negative 3 is an x-intercept, it can't also be a vertical asymptote and a whole. Usually this doesn't work out. The way we find the y value of the whole is you plug in the x value of the whole into the reduced fraction. So imagine these being canceled out. And you would get 2 plus 3 over 2 plus 4. So 5, 6. Now, that's not a point on your graph, but we can still indicate it with an open circle. In fact, we need to. If we got points on your graph, that would be at least one of those points. Right, horizontal asymptote, so one you compare the degree of the numerator to the degree of the denominator. Since they're equal, it is y equals leading coefficient over leading coefficient. Y equals 1 over 1. An asymptote is only if the degree of the numerator is 1 bigger than the degree of the denominator. So right here. The domain has me take out the numbers that are division by 0, whether it's a whole or vertical asymptote. The domain does not care about that, just that you can't plug those in. So we have to skip 4, and we have to skip 2. Same thing, I really can't answer range until I can see the graph, so I can see what y values are being hit. I have a pretty good idea right now, but it's a lot easier with graph today. Y-intercept, plug in 0 for x, and you get 0 plus 0 minus 6 over 0 plus 0 minus 8. So negative 6 over negative 8 reduces to 2/3. Divide by 2, divide by 3/4. Okay. And you're always welcome to do more points. Sometimes it's necessary, but I can get a pretty good sketch without plugging in more points. I can see it hits these points. It doesn't hit the whole, but it's going to hit the points right before it and right after it. So I can see how those are going to be connected. At the end of the graph, this is going to plug up close to the horizontal asymptote. Based on the direction of this graph, I can see it shooting down on this side of the vertical asymptote, so up on that side of the vertical asymptote. Really, for accuracy, I probably should plug in one of these x values to see how close this is. Like, I don't know if it looks more like this or more like this. But since it's a sketch, anyway, for as much time as I'm spending on it, that's good enough. Okay, so now the range, I can see this all of the y values except for 1. So everything less than 1 and everything more than 1. Alright, and then to finish this one up, neither of those had a slant asymptote, so to make sure that you're not tricking yourself into thinking you understand slant asymptotes. How can you determine whether this has a slant asymptote? It is if the degree of the numerator is 1 bigger than the degree of the denominator. That was true for questions 1 or 2, and that's why I was able to say none of the slant asymptote and move along quickly. But when it is true, like this one, I would very much suspect, I mean, we're not going to get several of these on your semester test, but I would suspect there'd be at least one. You need to know that the process to find it is going to be long division, and that's going to be y equals whatever the quotient ends up in, not the remainder. So x times x gives you x squared, x times 2 gives you 2x. Change the signs and add so that you're ultimately subtracting, and that gives you x plus 8. And then the next part of your quotient is 1, because 1 times x is x, plus 1 times 2 is 2. Subtract all of this, or change the signs and add. You get a remainder of 6, but we don't care about the remainder of 0. Y equals just whatever the quotient is. So one extra thing that you could do on your semester test, we haven't talked about it yet, but you'll probably get a calculator in the whole test. You also just have to make the questions easier. So there's nothing stopping you from graphing it, and then going through and graphing where you think the sine asymptote is. And it better be a perfect fit in there. If your sine asymptote doesn't fit right in there, then you know that sometimes off. Okay, so again, I'm trying to say all of the rules that we practiced over several different weeks, which is a lot of information at once, but you have seen all of this recently. But if you have a specific question, I would certainly like to address that before we move on. Anything from parts 2 or 3 that I just said too quickly. Alright, so please, before you put this away, mark the stuff that you realize that you don't know well enough so that you know